I will discuss briefly the design of doglegged staircase in Matlab. Okay, let us once I will read this problem. Okay, design a doglegged staircase for a building in which the height of floor is 3.3 meters. Adapt rise and thread of each step are 150 mm and 225 mm respectively. The stair hall is 2.5 meter cross 4.5 meter. Then live load may be taken as 3 kilonewton per meter square. This is for not crowded, means that this is the residential building. If the building is crowded, we have to take the live load as 5 kilonewton per meter square. Then use M20 grade concrete and Fe 415 grade steel. Assume the stairs are supported on a 230 mm walls at the ends of outer edge of landing slabs. Okay, this is our problem. Okay, once I have written a generalized code. Okay, I have written a generalized code in Matlab. You can see here clear as usual. This is clear, close all and clear all, and format short. Format short is our output values, any value should we get in a very less decimals. Okay, less decimals. Then the proportioning of states. Then you have to give the input as enter the grade of concrete and grade of steel and diameter of the main rebar and the diameter of the distribution reinforcement, distribution bar, then length of stair hall in meter square, and then again we have to give the breadth, then height of the floor, then rise of stair and thread of stair, then clear cover of the slab of the staircase. Okay, then width of the support, then enter the live load and the floor load. Floor load generally tiles load. The floor load is generally will take 0.6 to 1 kilonewton per meter square. Okay, then HF, height of the landing, HF is equal to H by 2, that is height of the floor by 2. Then height of then number of risers and threads. This is the formula. Okay, this is the formula. Then what we have to do, then adapt the width of the staircase. You have to width of the staircase. Generally width of the staircase is 1.2 meters for residential buildings. For other minimum 1.2 for public buildings it will be somewhat more. Let us say 1.5 meter to 2 meters. Okay, then length required for threads will get, then width of the landing will get the width of the landing, then effective span, then thickness of the slab, then it will calculate the fourth loads. Okay, loads, then minimum depth required, then you will calculate the factored bending moment. Okay, if this condition is satisfied, D minimum, if D minimum less than D effective of the slab, then waste slab, then provided depth is adequate. If not, provided depth is not sufficient. Okay, then as usual tension reinforcement. Okay, tension reinforcement. Okay, then provide the reinforcement. You can use this printf. You can see, you know that other programming languages, just like C language, we have printf, but in this Matlab we have to use printf. Okay, printf. Then distribution reinforcement. The distribution reinforcement is all these things. Okay, very easy. So in order to save our time, so for repetitive calculations we use this Matlab. Okay, anyway, once we'll run this code. Okay, run this code. You can see here the change folder. Okay. See. Then we have to input. We have to input the required things. Then first enter the grade of concrete. Grade of concrete is 20. Then similarly grade of steel 415. Then enter the main bar. It is 12 mm. Then distribution reinforcement dia is 8 mm. Then enter the length of stair, that is 4.5 meters, and the breadth is 2.5 meters. Then the height of the floor is 3.3 meters. Then rise is 150, minimum 150, and thread is from 220 to 200 to 225, like that. Okay, 225. Then enter the clear cover of the slab of stairways, that is generally 25 to 30. Then width of the support 0.23. Whether the width of the supports may be beams or walls. Okay. Then enter the live load for public building, for residential buildings 3, and enter the floor finish load. Floor finish load is just like 0.6 kilonewton per meter square. Then see number of risers and threads. Number of risers is 11. You can see here. The number of threads is 10. Then adapt the width of the staircase. Adapt the width of the staircases. I am adapting 1.2 meters. Then you can see here factored minimum depth required. Provided depth is adequate. Okay. Provided depth is adequate. You can see here minimum. You can see here. You can see here the width of the landing, that is 1.125, and effective span is the thickness of slab. You can see thickness D effective is 190, and after adding our cover, clear cover, that is 190 plus 30, then we got 220. Okay, we got 220, and you can see here tension reinforcement. The main reinforcement is 810.8166. This is the minimum reinforcement. Okay, we got two values for our AST square. AST square, that is 10 power 3 into 8.3458 and 10 power 3 into 0.8108. But we have to take the minimum reinforcement. We have taken the minimum reinforcement. And the spacing is 140 mm. Provide the main reinforcement with spacing center to center as 140 mm. Similarly, distribution reinforcement. The distribution reinforcement that is 0.12% of the gross area to 0.12%. Then provide the distribution reinforcement with spacing. The distribution reinforcement along the width. Okay, along the width of the staircase we have to provide 191 mm of 8 mm dia. Okay, this is the basic thing we have to remember. We have to understand how the Matlab solve very easy calculations at time taking calculations within seconds. Okay, so in the next class I will tell you some important online course regarding Matlab, that is okay, online online ramp course. Okay, online ramp course. Okay, then you will get a certificate also. You will get one certificate also. Okay, certificate. Okay, I will make a video on how to enroll online ramp course and how to get the certificates. Okay, anyway, thank you for watching this video. Thank you.